Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. एथरे मु ऑलरेडी प्लस 2 सेकंड ईयर सिलेबस कंप्लीट कर सारछि एबे मु प्लस 3 सीबीसीएस ऑनलाइन क्लासेस रो वीडियोज गुडा अपलोड करिवि जदि भल लागिला ताले लाइक कर देबो एवं सब्सक्राइब कर देबो जो वीडियोज गुडा मु अपलोड करिवि तार नोटिफिकेशन पई एठी बेल आइकन को ऑल रे सेट कर देबो गोटे इंपोर्टेंट जिंस वीडियोज रो ऊपर एठी जो 3 डॉट्स देखुछो तार क्वालिटी एठी देखो बाय डिफॉल्ट 360 अछि तमे ताकू पढे मध्ये परिबो एठी एडवांस रे क्लिक करी तमे रिजोल्यूशन बढ़े परिबो प्रति वीडियोज रे मु पीडीएफ लिंक देबी ताकू एठी ड्रॉप डाउन लिस्ट रो तमे क्लिक करी डाउनलोड मध्ये करि परिबो पीडीएफ को लास्ट रे एठी जो मोर चैनल नेम अछि याकू क्लिक करी तमे एठी प्ले लिस्ट को जाई मु प्रति वीडियोज को यूनिट वाइज एज पर सिलेबस सजाई की रखिथिबी तमे सर्च करि परिबो ओके थैंक यू
हेलो स्टूडेंट्स आज टॉपिक रे हमें ट्रांसमिशन इलेक्ट्रॉन माइक्रोस्कोपी विषय रे पढ़िबा which is one of the direct detection technique for the nanoparticle characterization. Now we know that the electrons can be produced, focused, accelerated to high energies, and they can be converted into a collimated beam very easily. Now these highly energetic electrons will have wavelengths having order of picometers, that is 10 to the power minus 12 meter. Now, a transmission electron microscope, in short TEM, uses this energetic beam of electrons to provide topographical, morphological, compositional and crystallographic information on the samples or specimens. Right. Now, the first TEM was built by Max Knoll and Ernst Ruska in the year 1931. Right. Now in the TEM experiments we use a focused beam of electrons which is transmitted through an ultra thin specimen under ultra high vacuum which is maintained at a pressure of around 10 to the power minus 4 Pascal, and thereby it will interact with the atoms of the specimen, and now when they pass through this specimen, after that an image will be formed, okay, from the interaction of electrons which are transmitted through the specimen, and this image is magnified and focused onto an imaging device which may be a fluorescent screen on a layer of photographic film, or it can also be detected by a sensor like a charged coupled device, in short CCD. Okay, now as far as the resolution point of view, TEM is having a very high resolution which is around 0.05 nanometer. Okay, so up to this range it can focus the object. Okay, so because of the small d Broglie wavelength of these high energy electrons, it is possible. Okay, so this enables the TEM to capture very fine details, even as small as your single column of atoms. Right. Now TEMs actually they produce high resolution two-dimensional images which gives a wide range of educational, science and industrial applications, right, and it is a major analytical tool in physical, chemical and biological science, right. Now you can see in this figure, you can see the left side is the schematic diagram and the right side is the image formation in case of TEM. Okay, so on the top we have an electron gun, thereby the electrons are produced from this gun, okay, and they are going through this conduction lens which is used for focusing these electrons. Now we have a sample at which the electron beam will interact, and thereafter we have a objective lens, okay, and finally we have the phosphor screen on which the image of the sample will be formed. On the right side, if we see the image formation, this is the source, then the lens for focusing, then here we can see these are apertures, okay, these apertures actually are blocking the marginal range. Okay, marginal range means the rays which are close to the margin of the lens. So these blockers or apertures are blocking the marginal electron beam rays and only allowing the paraaxial rays, okay, which are close to the principal axis, right? Now this is the specimen, then objective lens, then your projector lens. Again we are using aperture in order to block the marginal rays. So after the projector lens, the image is formed at the last at your projector or phosphor screen. Okay, now let us see the principle of this TEM or transmission electron microscope. So as we have seen in the figure, it consists of an emission source, which is tungsten filament or LaB6 source. LaB6 means lanthanum hexaboride. Okay, it is a chemical compound. Okay, so the ଏଠି जो electron gun ଅଛି, here there will be a filament. Okay, there will be a filament. So the material of this filament should be like having a high melting point such as tungsten, or those with a low work function which is lanthanum hexaboride. Okay, so this is required for the filament of the gun. Now the electron gun is given a very high voltage around 100 to 300 kilovolt, and it emits the electrons by means of thermionic emission or by field electron emission, right? Now the electrons will be focused by an objective lens, and they are amplified by magnifying projector lens, and finally they produce the desired image on a screen. Now we have already seen in the above figure about the basic principle of conventional TEM as shown in the schematic diagram and its ray diagram showing the image formation, right? Now we know that electrons are charged particles, they are negatively charged, so they can be easily influenced by external electromagnetic fields. Now the electromagnets can manipulate these electron beams. Also electrostatic fields can deflect the electron beam through a constant angle. So these two opposing deflections will give rise to a shift in the path of the beam. Hence, the images are formed because different atoms interact with and absorb electrons to a different extent, right? So finally, the observed image will depend upon two factors. Number one, the amplitude of the electron beam as well as the phase of the electrons, right? Now let us see the modes of operation for a TEM. So the most common mode of operation for a TEM is the bright field imaging mode. Here the contrast is formed directly by occlusion, means obstructions or blocking, and absorption of electrons in the sample, right? Now the thicker regions of the sample, that is the regions having higher atomic number, will absorb more number of electrons and hence will appear dark, while the regions with no sample in the beam path will appear bright. Okay, so this is why the name bright field imaging is given to this mode. Okay, and the image which is formed is due to undeviated transmitted electron beam. Okay, another mode of operation of TEM is the diffraction image observation mode, where the contrast is produced by Bragg scattering or Bragg diffraction of electrons by the atoms of the crystalline sample, and this method can be used for identification of lattice defects in the crystal. Okay, so the position and type of defect, that is your lattice defect, can be accurately determined by using this method, and this mode is also called as selected area electron diffraction mode, that is in short SAED. Okay, now let us see the magnification which can be produced by this TEM or transmission electron microscope. Okay, here the magnification is due to the ratio of the distance between the specimen and the objective lens image plane. Okay, and TEM has the ability to change the magnification simply by modifying the amount of current that flows through the coil, that is the filament coil. Okay, also quadrupole or hexapole lenses. Okay, so it can modify its magnification. Now higher resolution imaging require thinner samples. Okay, and higher energy of incident electrons. So for best results, the film thickness should be of the order of mean free path of electrons in the sample, so that the sample will be thinner in size. Okay, and much thinner films exhibit too little scattering to provide useful images, and in the thick films the multiple scattering events will dominate, making the image blurred. Okay, that is why thinner films are the best for the TEM sampling. Okay, and it will be difficult if we take thicker films. Okay, it will be difficult to interpret the image. Okay, so image processing can be used to increase the information which are obtained from a TEM image. Okay, now let us see the application of TEM. So transmission electron microscopes find the applications in various field. Okay, medical field ro application jodi ame dekhiba, like your cancer research. Okay, cancer cell detection re eta use हुए. Then virology, material science, nanotechnology, then semiconductor research. तापरे lattice structure of material can be determined by this TEM. Now the shape of the sample can be determined from the image of your TEM. Okay, and TEM can be used to detect the flaws, fractures and damages which are produced in the micro sized objects. Okay, so it is very helpful to detect the defects which are produced or damage which are produced in the micro size objects. Now the imaging capabilities of TEM are added, that is complemented by diffraction patterns for structural studies and spectroscopic techniques for the chemical analysis. Okay, so these are some of the applications. Now let us see some of the advantages and disadvantages of TEM. So number one, the transmission electron microscope will provide most powerful magnification of 1 million times or more. So this is very huge. Okay. Number two, it has wide range of application in educational, scientific and industrial fields. Okay, for research purpose. Now number point 3, TEM can provide information on element and compound structure. Then it forms detailed and high quality image for samples. So it produces highest resolution images. Okay, so it has a very good resolution power. Okay, then number 5, it can be operated very easily. Okay, and it yield the information of surface features, shape, size and structure. Okay, so এই ସବୁର information ଆମେ TEM ରୁ ବାହାର କରିପାରିବା surface ର. Okay, however it has some of the disadvantages or drawbacks. Number 1, TEM are large. Okay, their size is large and very expensive. Okay, they are very costly. Then number 2, as we have studied, in case of TEM, the sample size should be very thin, up to few nanometers, and for this extensive sample preparation technique is required in order to produce a sample which is thin enough, around 10 to 100 nanometer, to be electron transparent. But producing these thin samples is a very difficult task. Okay, and we also know that as we approach towards the nano level or nano dimension, the characteristic of the material also changes. So these thin samples may not represent the larger object to which they belong. Okay, so the larger object may be representing some other characteristic and the thin sample may represent some other characteristic. So this is also possible. Okay, which may lead to or drawback or disadvantages of TEM technique. Now, point number 3, TEM analysis is relatively time consuming process and it requires special training for its operation. Okay. Number 4, the sample may be damaged by the electron beam because electron beam is very highly energetic. Okay, and they are interacted with each sample, so it can damage the sample. Number 5, the TEM has a relatively small field of view. Okay, and thus at a time a very small portion of the specimen can only be observed. Okay, number 6, the structure of the sample may get changed during the sample preparation process. Okay, and finally number 7, complicated contrast mechanisms which makes the image interpretation difficult. Okay, so this is all about the transmission electron microscopy or TEM. Now I have taken the TEM topic from another book also, but here it is given in brief. Okay, so I advise you to study it and also study the first one. Okay, and you can prepare your note accordingly. Okay.
Thank you.